Hey everyone, we're going to be doing a Unit 1 study guide for AP Human Geography here. The study guide, the blank document, is found in the description below. You can fill it out, you can do it with me, you can check over your answers, whatever you want to do. We're going to be going through 1.1 all the way up to 1.7 in that order. And yeah, we're just going to really discuss some of this content here. And so we're starting out here in the basics. We're looking at just what are maps and what do maps show. And so we have this word cartography. We need to define it. Well, we're talking about maps, and cartography is just the science or the art of making maps. So I'm going to say science of map making, but you could say the science, the art, something to do with composing maps. That's what cartography is. Now, on a map, we have something called toponyms. What are those? So those are just place names. So the United States is a toponym. Florida is a toponym. Minnesota, Washington, D.C., North America, Earth, those are all toponyms. Then C, describe the purpose of a reference map. None of these maps here are reference maps. If you are trying to find something to reference, these are all thematic maps. And so what's shown on these maps? Quantitative data for the most part. So we can kind of answer that here on the thematic map. We can say to show quantitative data, and I'm just going to abbreviate that to quantit. So show quantitative data / you could say a geographic theme or some kind of phenomenon. So that's what a thematic map shows. But reference maps do not show quantitative data. They show really location of different places that you can reference. Okay, where is California? That's what you would use a reference map for, to find where California is or where is the Indian Ocean. It can be used for other just geography features. It's used for navigation. And then, of course, you could say just examining physical geography as well. So you want to see where land is, where water is, where maybe a river is, or the ocean, or a bay, or the sea, something like that. This navigation here, I spelled it right. It just doesn't look that good. All right, so I am writing that out. We have qualitative. And the N in quantitative, that deals for numbers. And then qualitative, you just think of quality. Anything non-numerical is qualitative data. So location, navigation, physical geography, that sort of thing is qualitative. And then quantitative data, it's like the population or the temperature, what we're looking at here on these thematic maps as well. And so we're just identifying the type of thematic map shown here. So for this first map here, we're looking at average temperature. And a lot of you would say this is a core plus map, clearly, because we're using different shades of color to represent different values here. And that's not right, because we are not confining the colors to any particular type of entity. So like, look at Texas. It's not all one color. Same with Florida, or same with California. These are all not just one particular color here. We are using lines to connect points of equal value. So this whole region here is all about 20 degrees Fahrenheit. And so we know that when we use lines to connect points of equal value on a map to kind of show a continuous surface of data. So we're using continuous temperature values. We call those isoline maps. They don't have to be straight lines, and they're certainly not in this case because temperature is not a very uniform data piece. But we are using predominantly lines to represent equal values here. We're not looking at anything more specific than 20, 30 degrees, 40 degrees. We're not looking at 44, 45, that sort of thing. Moving on to this next map, though, however, the data is confined to particular entities here. We can see there's no variation within the states. We're not using lines to represent data values. This is a choropleth map, clearly a choropleth map. This is probably the most common type of map you'll see in this AP class, and this is 100% what a choropleth map looks like. This one here, we are using a symbol, a circle, isn't that great, to represent population values. We're also using the different shades of the symbols as well. But the bigger they are, the more population is. That's pretty clear in these states here. There's not a lot of people living there, so the symbols are very small. So this is what's called a graduated or a proportional symbol map. And this next one here, we are using, looks like dots to represent where U.S. public libraries are located. So we can see there's a big cluster there. There's not a lot of libraries over here. Most of the libraries are pretty much in the eastern hemisphere of mainland United States. And we call this a dot distribution map. A pretty easy name if you're using dots. Each dot here has an equal value of one US public library. And so F and G are using this map here, and I've kind of already answered these. F, identify a cluster of public libraries in the US. And so the easiest one I would say of where a cluster is, you could say New England, or you could say the northeastern region. And a cluster is just where things are concentrated together. Where are libraries in the United States concentrated? You could say even just eastern United States, the Northeast is what I would say. You could say northern Georgia if you wanted to as well, if you want to get pretty specific as well. You could say southern Michigan, whatever floats your boats. Now we're identifying a dispersal of public libraries in the United States. And a dispersal is it's just the opposite of what a cluster is. A dispersal is where things are spread out. They're not concentrated, they're not accumulated. And so a dispersal here, you could honestly just say Western United States. There's not a lot. You could say Western Texas if you wanted to. You could say Nevada if that really floats your boat. I'm just gonna say Western America. Boom. All right. Which thematic map is best for displaying data on elevation? Which of these four particularly, is best for displaying data on elevation here? And I'm going to say that an isoline map is best for displaying data on elevation, because we look at this temperature map, it displays the temperature very nicely. Even though there's like obviously more specific temperatures in 80, 90, 100 degrees, there's a lot of more specific elevations as well. You can go 1, 2, 3, 4, 5, 6 feet, or you can go 100 feet, 200 feet, 300 feet, and it'll connect different points across the United States together, particularly because different states have different elevations. Like the elevation points across Florida are relatively different from one another. So if you're closer to the coast, you're closer to sea level, but once you get more mainland, you can actually get a little bit below sea level, you can get above sea level, that sort of thing. And so isoline, I think, is the best map for displaying elevation here. You want to display maximum elevation, maybe a choropleth map would be better, or maybe a proportional symbol map. But if we're just looking at elevation data, maybe across a mountain range or even the entire country, an isoline map is going to be the best. Now, which thematic map is best for showing a cluster of some kind of geographic trend? That's a dot distribution map for sure. And we saw that with our public libraries map right here. We can see clusters and dispersals very clearly. If we go to this choropleth map, we can, look at New York State here. New York State has a good bit of public libraries, but we don't know where in New York they are. And if I had to guess, they're probably closer to where New York City is, maybe not out in the western region here. And if we look to other states here, like North Dakota, North Dakota has libraries. We just don't know where they are. For all we know, they are clustered in one particular spot, even though there's just not a lot of them compared to other states like New York, California, or Florida. J, explain why all maps are wrong. It's impossible to take a 3D globe. The Earth is not a perfect sphere, but spherical enough, and it's impossible to take something 3D and plan it to a 2D map or a 2D piece of paper. You can't do that. And so you're going to get some kind of distortion when you take a 3D solid and try to plan it on a 2D surface, like a piece of paper. And so what you get with that is distortion on maps. And we can see that with these projections up here, that we get some kind of distortion on our maps. And so what are the four characteristics that may be distorted? The first one is shape. We're looking at the shape of the land masses. The next one is area. And when we discuss area, we really mean the size of the land masses. So you can use area or size synonymously. But if you're on the AP exam and a multiple choice question asks you about area, they're really talking about the size of the countries. What else is direction? Can I get from point A to point B as the map says? And then, of course, the distance, how far apart are the places or the land masses are on a map. And so let's look at some of these projections here. Some of them are more familiar than others. This first one here is the Mercator projection. This is probably the one you've seen the most. This is the one Google Maps, Apple Maps use it. It's been used for 100 years for navigation. It's really good for compass usage. So that's why it's been used for navigation. And so what is distorted? And we could say area is distorted. More particularly, as you get closer to the poles, the area is a lot more distorted here. They get a lot bigger. And so the closer you get to the equator, the nicer the country's area are. But the further away you get from the equator, closer to the North Pole and the South Pole, the size of the land masses get much, much bigger. And then looking at this one, identify what is distorted on this is the Gauss-Peter projection. You've probably seen this one as well in your course, maybe not before the course, but certainly in the course now. And this is what's known as an equal area projection, I'll write that here on the side. It's known as an equal area projection. And that means that the areas are pretty preserved. So the size of the countries is pretty prevalent here. We can see Greenland is not as big as it is on the Mercator projection here. You can fit a good bit of Greenlands in Africa, which is the truth. You can. And so what does that distort though? Well, obviously it distorts the shapes. I mean, look how scrunched up Greenland is. Look how kind of like pushed Africa is, especially when you get to Canada, it kind of just looks scrunched together. So the shapes are definitely distorted. We also are distorting the angles as well. And this doesn't make it a good map for navigation as a result. Moving on to the next one here, this is the Robinson projection. You've probably seen this one before the course, and you've seen it in the course as well. This is the Robinson projection. It's called a conformal projection, and it distorts a little bit of everything. So it distorts area, distance, direction, and shape to kind of make this nice visually appealing map that we have here. So a little bit of everything. If you want to write all four, you can. I just don't want to. Little bit of everything is distorted here. It's a little bit of compromise. You minimize distortion for all four characteristics, but you still have it. It still exists. So it's not perfect. All maps are wrong, as we know. And then N, identify what is distorted on the watermelon projection. Notice how I didn't make you write down what the name of this was. I don't expect you to know what the watermelon projection is. It doesn't even look like a watermelon, which is so sad. It's like the Washington Monument. It doesn't look anything like George Washington. So what is distorted on here? Well, the shapes are pretty well preserved. I can just tell by looking at these. They don't look very scrunched up or expanded at all. However, what is distorted, and I think this is pretty clear, is the direction here. And you can just compare the Robinson projection, the watermelon projection. The directions here are definitely not that accurate at all. Like if I go directly right here on the top of South America, I'm going to go there. But if I do that here, I'm going to go here. And so those are clearly different places. The other characteristics that's distorted is distance as well. And I think that's another pretty clear one. You don't have to know like the distances between Australia and North America. But distance is clearly distorted here. Not so much in the middle, but a lot more on the exterior of the watermelon projection. I thought this was just a cool projection to show you and to stress you out a little bit. But let's move on to 1.2, geographic data. So we have some easy true or false ones here. So true or false, remote sensing captures, stores, analyzes, manages, and presents geographic data. And that sounds like a pretty handy dandy definition, but it's not true, it's false. We call this a GIS. A GIS does all this. All right, the next one, a GPS always uses absolute location. That is true. It never uses relative location. It uses absolute location and wants to know where exactly you are on Earth. The next one, GPS can provide absolute direction and distance. And that's true. My car navigation system, which uses a GPS, does do that. Moving on to B, define remote sensing and identify two uses for it. So I'm just going to tell you the definition. I don't want to write it out, but a definition of remote sensing would be to acquire information about an object or an area from a distance. And I'll actually write that here, from a distance. And so satellite imagery is the greatest example of remote sensing. So you can do that from a spacecraft. You can also do remote sensing from aircraft. That's pretty common as well. But you're not the one like going up to a farm and taking a picture. You're having some piece of technology do it from far away, not at the farm. So that's why it's remote. It's like when you work a remote job, you're not actually at the office, you're somewhere else, like the beach or whatever, or your house, if you want to. I would like to go to the beach and work if I had the option to. So yeah, that's remote sensing. And two uses of it. There's a lot of different uses. The one I want to talk about is land use monitoring. So you can monitor a farm or urban developments or any kind of development for that matter. And also you can use it for surveillance. And the military uses it a lot for protection and surveillance as well. Weather monitoring is also a popular one for a GIS. So you could do like hurricane tracking. You could do that with a GIS, or you could do it with remote sensing. Not really with a GPS though. And then identify two uses for a GPS. So this is where we go into using our absolute location, our absolute direction, and our absolute distance. And so traveling is a popular one, traveling from one place to another. I certainly use my GPS a lot in my car. And then another one is you could be using locating people in need. So just location of people. EMS services will use this to get to houses for help. House arrest, if you have an ankle bracelet, that uses a GPS as well. Then we have identified two uses for a GIS. And so urban planning, of course, you can use urban planning with a GIS. and track and see what's being used on particular land in an urban area. Also, weather tracking. So you can track weather with a GIS as well. Those are pretty popular uses. You can also kind of use these for with remote sensing. Just use them in different ways or use them together to get a bigger picture. That's the great thing with technologies. We use a lot of different technologies together to get us information. Identify two cons of GIS technology. Well, first off, it's expensive. It is expensive to use. It does cost money. And of course, technology isn't perfect. So you can get inconsistent or outdated data. So it's important to update data over time. And like, look at Google Maps. Google Maps has the street view. However, what happens is that streets change. Houses get torn down, buildings get put up, roads get repaired, or new roads form. And so data is not the same over time. And so that's a downside to most technologies, is that you have to update the data pretty frequently. Then F, identify three other ways geographic data is collected. There's a bunch of different ways. I'm going to highlight three. Media reports is the first one. So media reports, then you could say field observation. So actually going out and observing the data yourself with your eyes. That's a pretty good way to collect geographic data. So I say, oh, wow, all these people are wearing blue shirts in this city. That's interesting. That's a geographic trend. Then we have photography as well. Taking pictures. If you take a picture, it'll last longer. So photography is a good way to collect geographic data as well. Travel narratives is another one that people will talk about their travel experiences and what they saw and what they did and that sort of thing. All right, part G, identify the geographic technology shown in the image here. So this first one is showing a particular place. We're looking at geographic data. It's a little blurry, but it's supposed to be because you're not supposed to see what they're actually looking at here. But we're looking at land use particularly, and we're highlighting different areas of land. This is a GIS. We are analyzing and storing and displaying geographic information here. And then this one's of a hurricane. It's a picture, it's a satellite picture, it's remote sensing. On the AP exam, they may even just say satellite imagery, and that's going to be the best answer here. All right, H, identify three pieces of data collected by the census. There's a lot of different pieces of data, but the main one is population. And some other ones I want to highlight is income. They also look at race data, ethnicity. They also look at household size, and that's a big one as well. So these three are really big pieces of census data that are used by both the government and businesses. But one way that the government uses the census is to establish voting districts within the state. So let's say you're in Texas. Every voting district has to be the same in terms of population. So that's why the census comes in handy. If it was just same in size, then we wouldn't need the census because the census doesn't take the size of a state. Another way that the government uses the census is for funding or resource allocation. So they may see, okay, this particular town has a lot more people coming into it, a lot more families. We need to build more schools. So that sort of thing they can use the census for. But businesses can also use the census here. They can use it for determining a target market or where to locate the business because they want to be where the people are, particularly people who will buy their product. And so they're going to use the census to see where a potential market could be to open up shop. So let's say they're a restaurant that caters towards college students, like Chipotle, Cava. I see those around college towns, particularly mine that I live in. So they're going to open up where college students are living. They can use the census to determine where in that city that they're living. Maybe they're living on campus or off campus. The census is really good at that. They can also just find a workforce. So not only a market, find a labor pool because they need people to actually do the job or else they wouldn't have any products to sell. So finding a labor pool is another reason that businesses would use the census. Now, how is the census conducted? How often? Well, it's done every 10 years. And it's done through door-to-door surveying, so not particularly online. However, the one exception to this is in 2020, but a pandemic happened in 2020. So that was their reasoning for doing the census online. But door-to-door surveying is how they've always done the census before that, and that's the way they'll probably do it continuing on because it's a very efficient system. All right, L, identifying two environmental uses for satellite imagery. So the keyword here is environmental. And so we could look at natural disaster effects. We can also look at just what a hurricane looks like, as we saw in that picture. But looking at the effects as well is a pretty common way of using satellite imagery. And then another one is, we also say just urban development. We can say farming as well. It's like, or we look at the effects of farming, see if there's been any drainage in water sources, any environmental effects of farming. So I said urban farming. We can say urban/farming as well, whichever you prefer. So a lot of similarities between some of these questions here. Identify choose is for satellite imagery by business here. That's the key word here. Well, let's say you're the farming business. You can monitor your crop growth. Or not no crop growth, that's happening as well. You can also look at construction progress as well, or other kinds of surveillance. That's another possible answer here. A lot of answers here, tons of different answers. All right, 1.4. We're going to talk about spatial concepts now, starting with distance decay, which I'm sure you're familiar with by now. So let's draw a graph to represent that. And so here we are going to have the distance here. So the distance I get from a place. I'm from Florida, so this is the distance away from Florida. And then we're going to say interaction here. Let's see if I can fit that. Interaction is on our y-axis. So by interaction, I mean communication, I mean going to the place, knowing people from the place, completing business transactions, all of that. We get a exponential negative graph here. And so the definition of distance decay is the further away I am from a place, the less likely I am to communicate or interact with it. So I'm from Florida. I'm more likely to travel to Georgia than I am to travel to New York or Maine or California because Georgia is closer. Now we have this concept known as time-space compression. Essentially, the world feels smaller. The world feels compressed. I mean, it's in the name, time-space compression. And that what we mean is we're decreasing the relative distance. That's the key word here. So in the AP exam or your test in class, your teacher may ask you this. We are decreasing the relative distance between two places. And that's what time-space compression is. And it's due to the fact that we have innovated our technologies in communication, I'm just gonna put comms, in transportation. Just gonna put transport. Honestly, I'm just gonna write transportation, you know. So communication, things like texting and phone calls. I mean, the telegram, for one, in the 1800s, that was revolutionary. And then for transportation, of course, air travel is a big one. Cars, boats, those are all big ways that we can get to places a lot quicker. We can talk to people a lot quicker. I can talk to someone in India, even though their times are a lot different than mine. Even though they may be sleeping, I'm awake. I can just use my phone, send them a text to get it in 1 minute, and it's great. And they can respond back to me with a meme or something. Transportation, I can get to India in less than a day. Isn't that amazing? Back in the day, no, that would take forever. It took the pilgrims over 2 months to get to the United States from Europe. And it won't do that anymore. I can get from the United States to Europe in less than a day. Isn't that amazing? All right, moving on to E, identify 3 effects of time-space compression here. So we're not saying the world feels smaller. No, we're looking at 3 effects as in like what's prominent because of time-space compression? Well, now we have mass media. I can access media from the United Kingdom. I can access media from China or Iran and see their news. And likewise, they can read American news as well. We also see global economic exchange, and that sounds very fancy, and it really is because it's revolutionized our economy. Global exchange. I'm just going to write that in the money. Yeah, because I didn't write global economic exchange. So I can trade, or I guess countries can trade across the world. Imports and exports are a lot bigger than ever. We have stock markets now, which is pretty amazing. So there's a lot more global economic activity going on relative than local economic activity or local exchanges. And of course, we see pop culture, Taylor Swift, Marvel, Disney. I wrote Pop Swift. Isn't that amazing? Yo, I'm not even going to cut that out. Pop culture, boom. That's become a big phenomenon because of time-space compression as well, especially the internet. The internet just changes everything. All right, give 2 examples of absolute location. I'm not going to give 2 specific examples. You should, though. But the 2 really examples you could give are 2 addresses, or you could give 2 latitude and longitude coordinates, or one of each. These are the best examples of absolute location because they're unique to a particular place. But relative location is not unique to a particular place. So I could say left to the store, and I'm not being specific. What store am I talking about? because left to the store, and I'll also not say how much left, 10 feet, 10 miles, that sort of thing. Or I can just say close or far. These are all relative locations. For one, it's perceptual. What I think is close may be far to someone else, and vice versa. Part H, identify one example of absolute direction. So really anything that's given through compass coordinates, compass bearings, as you may, these are all examples of absolute direction. And then one example of absolute distance, you can just use any unit. I'm gonna say 10 miles away. You can say 10 inches away, and that is also an absolute distance as well. And then identify one example of relative distance. You could use something like time, 20 minutes away. That's the greatest example of relative distance is time, in my opinion, because something can be an hour away, but be a short distance, but something else could be an hour away, be a long distance. Like, if I'm in the city, I'm not gonna get very far in an hour. But if I'm in the country, I can get pretty far in an hour. All right, enough of me rambling. Let's move on to human environment interaction here. So we're gonna define sustainability here. So what this means is that we are using resources, not human resources, humans. No, we're not using humans. We are using Earth's resources, water and oil and food like fish and that sort of thing, using resources that meets the needs of the present. So we're meeting the needs of the present and of the future generations. So what we mean is that I am not depleting the Earth's resources in a way that future generations will not have access to water or access to food or access to oil or that sort of thing. That's what sustainability is. And so some examples of that would be reduce, reuse, recycle. You learned that in kindergarten. Recycling is a good one. And then another sustainable way is to not pollute water, not pollute the air, not pollute the environments. I'm just gonna say not pollute water. These are just examples of sustainable practices. There's a lot of them. These are just two of them. Moving on. Give an example of environmental determinism. So determinism and positivism, they are essentially theories about how humans interact with their environment, hence human-environment interaction. And so determinism says that the environment limits our ability to develop societies, build cities, and that sort of things. We are constrained by the limitations of our environment. So an example of that is in Antarctica. We have not built cities there because it is very cold, it is not sustainable to life, and there's just a lot more better places. And so, yeah, that's environmental determinism. We are limited by the cold environment of Antarctica. Plus, it's ice. It's not very good at farming or building cities on. And yeah, pretty interesting. Moving on to D, yay! Identify the following as determinism or positivism. Climate zones impacting crop growth. Climate zones impact precipitation, temperature, that sort of thing. And certain crops need a particular temperature range or a particular precipitation amount to grow and to be harvested. And so a crop grown in a tropical climate may not be able to be grown in a polar climate. So that is determinism. We are confined to the environment and what is presented to us. The next one, irrigation techniques in agriculture. That is an example of positivism because we can use irrigation to bring water to areas that may not have access to water or bring more water in as we see fit. And so we're overcoming limitations of our environments. We also move water, and sometimes water can be hard to move, so we can bring water from a river and bring it over to our farm. That's positivism. Then E, true or false, very simple. Positivism believes that the environment does set some kind of limitations on human development. That is technically true. However, it doesn't finish it. And what positivism says at the end is that humans can overcome these limitations. So positivism isn't that humans just have a free-for-all with the environment. It does claim that we have limitations that the environment gives us. However, we're able to overcome many of these limitations. Moving on to scale and scale of analysis. I feel like scale of analysis is one of the easier topics of this unit, but students get it so confused so quickly, and that just makes it a lot harder. So let's see if we can simplify this as much as possible here. And so the easiest definition of scale of analysis is, what are we comparing the data between? Are we comparing it between countries? Are we comparing it between cities? Are we comparing it between continents or supranational organizations? Like, are we comparing economic data of the EU versus the African Union, that sort of thing. What are we comparing the data between? So for this first map here, we are comparing data between countries like the United States, in Egypt, in Saudi Arabia, in India, in Australia, and New Zealand, and the United Kingdom, and Canada. Like, we're comparing data between the different countries. It doesn't matter what the data is, it's compared at a country by country basis. And so this is a national scale of analysis. You also say on an FRQ country, that works as well. National is just the cooler term. And then on this next map, we are comparing data per continent. That makes it a continental scale of analysis. So hopefully you are seeing the trend here. The next one, we don't have the map, we have a graph, but that's okay. We're comparing different cities here. So Chicago, Los Angeles, we are looking at Phoenix and Philadelphia. We're comparing the populations on a city by city basis. So that's a city scale of analysis. This next one here, we are looking at a particular place. I actually have no idea what place this is, but it's a place. This is the Pacific Ocean. So this looks like the United States, like northwestern United States. And we're looking at different, this looks like environmental data, but it's pretty local. It's pretty specific to various local areas. So that's a local scale of analysis. So if you don't know a particular place that's shown on a map, kind of use your context clues. For one, we can see that this is on the western coast of either the United States or Canada. I'm pretty sure it's the United States, up in Washington, Oregon area. And then use the data a little bit, but you can also see that the data varies very greatly. It's not very consistent or uniform here. It's very confined to local areas. We don't know if those are cities or counties or even streets. So local is the best answer here. Now on this graph here, many of you may have been tempted to say local because cities are pretty local. Like, the cultures in the cities vary significantly. They're pretty local areas. However, local is more of a subjective term. So on an FRQ, city is the best answer because yes, we are definitely comparing different cities. But if you go to like New York, there's different neighborhoods within the cities that have their own different sense of place and their different charm and culture and economies. And so that's pretty local as well. So city is the best answer here. It's like when we go to continental, many of you may have said regional because continents are regions. But continental is a better answer here because that's just a more well-known answer. So make sure you do that on an FRQ. You give something that's more well-known, a better answer. Give the best answer that's possible. Moving on to these two, we are looking at, this is religions across the world here. So the purple is Christianity, the green is Islam. I think the orange is Hinduism, and then the yellow is Buddhism. I'm just showing this off. That has nothing to do with the question here. But what is the scale of analysis? Are we comparing the data between different countries? Well, if you look at Canada, we have two different values here. So we're not really looking at that. Same thing with China. We have lots of different values. Australia, nothing's confined to a particular place. There's no pattern here. Some countries are entirely one particular color, while some countries are not. And so this is a global scale of analysis. Most global scale of analysis here are shown on a world map. Not all the time, but very most of the time. And that's when the data is just not confined to a particular place. Now, our last one here, we are comparing populations in metro areas. This is irrelevant, but we're comparing it between California and Texas and Louisiana and Tennessee and Florida and Maine. They're all varying at a state-by-state basis. So you could say state, because that's what they're called. They're called states. Or you could say subnational. And so either of these would work on an FRQ. However, on a multiple choice question, College Board could give either or. They're probably more likely to say subnational on an MCQ, but both would work on an FRQ. What is a disadvantage of using the last map provided, so this map here, to analyze geographic data here? Well, we don't have any particular information about what's happening within the states. We don't see data distribution within the states. So we don't see data, or we don't see where the populations are located within the states, because there may be some clusters and dispersals. So we could see here, like in Texas, we're looking at metro areas. Texas, its main cities are on the East Coast. But we don't see that because we're not looking at anything more particular than just the entire state of Texas as a whole. What are the scales of the last two maps provided? So we just talked about scale of analysis. Now we're just talking about scales. And scale is an even easier definition. It's literally, what are we looking at? Are we looking at the world? Like for this first map, we're looking at the world. So that's a global scale. Are we looking at a country? That's what we're looking at for this second map here. So this is a country scale, or you could say national. those are our scales. If we're looking at a particular city, like if we're looking at San Francisco, California, that's a city scale. If we're looking at Africa, continental scale. If we're looking at the southeastern region of the United States, that's a regional scale. So hopefully you're getting the picture there. Now let's move on to the last concept of Unit 1, regions. So part A is to define a vernacular region. So a vernacular region varies from person to person. And we call these perceptual regions because they are up to a person's perception. What I may think is part of the South in the United States may not be the South for you. Define a formal region. These are defined regions. They are not up for interpretation. They are formally recognized, and they do not vary from person to person. So they do not vary. They are not perceptual. So a formal region in China is the same thing as a formal region in Algeria. And so we have some examples here of regions, and we're going to classify them as formal, nodal, or vernacular. And also, nodal, you could say functional. And that's my favorite way of saying it. I don't like saying nodal. I like saying functional. So this first one here is South Carolina. South Carolina has pretty defined borders. Those borders are not up for interpretation, so formal it is. Then we have the South. Same thing with the West, or the Midwest, or the North. The South is up to interpretation. Is Florida part of the South? Is Texas part of the South? What about Oklahoma? What about Maryland? Are those part of the South? Some people say yes, some people say no. It's up to interpretation, so it is vernacular. Then we have the Sahara Desert. It's a desert. It's defined by a geographic feature, and that doesn't vary from person to person. The geography is still there, so it's a formal region. Then we have a newspaper circulation route. So anytime of these routes, they're going to be nodal regions, functional regions, because they're all surrounding a node, this particular node being the newspaper. And so they're all in a particular area, they're all receiving the same product, they're all connected by that same thing. And that makes it a nodal region. Same thing with a radio station. A radio station, a particular area has access to a radio station. Once you leave that area, you don't have access to the radio station, you just hear static. And that's a nodal region. The function is the radio. Then we have a mental map of Ireland. And a mental map is a map I'm creating just off the top of my head. So if I had a blank piece of paper and I tried drawing Ireland, that's my mental map. And my mental map is going to be a lot different than the mental map of my teacher or my friend. It's up to my interpretation and how I visualize Ireland. And so vernacular is going to be the type of region. Next, we have the Rust Belt. Now, the Rust Belt is its boundaries are not defined by any kind of geographic lines, like it's not any particular states. It's by a perception and common history of deindustrialization. So a bunch of factories that sprung up through the Industrial Revolution that made cars, automobiles. Cars and automobiles are the same. Automobiles, textiles, steel, and other metals, that sort of thing. They all sprung up through the Industrial Revolution, but now they are just rusty buildings thanks to deindustrialization. And people just understand the Rust Belt as a particular area, maybe not a group of cities or a group of states, and so it makes it a vernacular region. It's up to interpretation. Next, we have the Muslim practicing region of Nigeria. This is actually northern Nigeria, if you wanted to know. And we know where Muslims practice. It's not up to interpretation. Like, we can count that data and see where Islam is particularly practiced compared to other religions like Christianity. And so that's part of a formal region. So any type of like religious practice area, or maybe a particular place where a language is spoken, particular ethnicity is found, those are all formal regions because that's where they're found. It's like, it's not up to interpretation. And I guess that sounds really dumb to say, like I'm just stating the definition, but it's true. Like I can say, okay, in England, they speak English. Someone can't disagree with me on that. You can't disagree with me and say, oh, in northern Nigeria, they don't practice Islam. Like, that's not true. So hopefully that makes sense. And so this is one that I see on tests constantly, not this particular example, but examples of religion or language or some other type of cultural elements. These are all formal regions. Anything with geography as well are formal regions. And then mental map's another one I see that's pretty popular in tests. That's a functional region. Not a functional region, it's a vernacular region. Vernacular, I wrote V, I promise I know what I'm talking about. It is vernacular.
Thank you so much for watching. Please like and subscribe. It really does help me out, and it costs $0. I have some free resources for you in the description down below if you'd like to use them. If you have any AP Human Geography related questions whatsoever, don't hesitate to leave a comment down below the video or send me a message on Discord. I'll see you guys in the next video though. Adios.